So the quadcopter is great for the lander because we can use it as a platform to test code on, essentially. So it'll be essentially like a scale version of the lander. It will replicate the same kind of rocket configuration as the lander, and we can run very similar code on it that allows us to see what's going to happen with the lander without, doing a huge field test, getting all the permissions to do actually rocket ignition and everything. So for preliminary testing, it's a great way to get our feet wet.
Flying devices can be pretty dangerous if you don't know if the software that's controlling these devices is not tested well, or you don't know all the cases that it can get into. So having a platform that allows you to do testing in a controlled environment is, I think, a huge benefit.
As far as the way the quadcopter is going to be used to do analysis, I think my primary interest is in autonomous control systems and the way that those will be sort of utilized to figure things out and to be able to sort of think a little bit about how and where it's going to land on the moon. Like the last 10 minutes is the big deal, right? I mean, you spend millions and millions of dollars getting this thing to the moon, right? If you don't get the last 10 minutes right, you're host. Right?
The lunar lander itself will have to fly relatively autonomously, and that it'll have to do whatever it's going to do without a lot of commands coming from back home.
There's different levels of autonomy that you can give it. You can give it the autonomy to keep itself level and you tell it where to go with the remote control, or, which is the thing that's going to be required, it's going to be completely autonomous. It's going to be based on a program, right? I mean, if this thing is on the moon, right, there's no way you can control it in real time. There's just no way that can happen. So it has to be able to control itself, and it's the same thing with it. If you can make that work with a quadcopter, then at least you'll have a start at understanding the sorts of problems that will be required controlling something like this.
So the main really important element of the quad rotor is the feedback loop, is the control loop. That's what really makes quad rotors work, and that's recently quad rotors have become a thing because you've been able to get a fast enough control loop that it can balance itself. Before, that was kind of a harder thing to do with gas engines and whatnot, but with these fairly low cost, small outrunner motors, you can do that fairly easily.
So the processor does all the calculations, make sure that if the quadcopter moves in a certain direction, that it compensates for that direction. So it will make one motor spin fast and the other one a little bit slow. So the processor will then send commands to what's called an ESC, electronic speed control. It's a device that controls the speed of the motor. We have 4 of them, so it will send 4 separate signals to the 4 ESCs that control the motors. So that's basically the main aspect of the quadcopter, the whole control loop that takes information from the gyros and also information from the receiver that gets its information from the transmitter, and that controls the ESCs, and that makes sure that everything stabilizes.
Right. The thing behind me is going to have rockets around the outside, three rockets around the outside, and a rocket in the center, a rocket motor in the center. Those are all going to have to be controlled differentially to control the attitude of the system. Right? And that's very similar to the way a quadcopter works. The way a quadcopter works is that the power that goes to the different engines is controlled by the computer software. And the computer software tells it, well, this one has to be a little bit less powerful, and so it will rotate that direction and shoot across. With a remote control, you basically do that by hand, right? With a quadcopter that's autonomous, then the autonomous software has to figure those, make those calculations and do the appropriate changes.
We can experiment a lot with making that quadcopter be more autonomous. Basically maybe we'll introduce a video camera and have sort of image recognition sort of thing, so it can figure out, there's a rock in the way, I better fly around the rock before I land, that kind of thing. That's the main thing I'm hoping to learn from it, is to be able to start, just the basic flying stuff, and then being able to integrate, try out some of the more autonomous features of a real lander.
Yeah, so if you can speed up your development by using a test platform, it gets you to the finish line faster. So, I mean, there's more than 20 teams competing for this prize. We all want to win. So anything that we can use to speed up development and to get closer to the goal is a big benefit for us.